Find the particular solution for this dE given that x equals to 2, y equals to 1. So first we take out this differential equation. We have to identify the method of solving this dE. So our variable here, it will be referring y and x. And then we can see our expressions here all in terms of y, means this one will be fully in the factor of y. So for the factor of x, variable of x, we can't see any variable x here, means our x is just a number 1. So for this question, we're using separable method. As you can see, this is factor of y, this is a x. So normally when we have two variable, but our expressions here only one variable exists, normally our dE can be solved by separable. So that's why we will separate this variable y back to the left hand side. So it will be y plus 3y squared dy. And then remaining one here is for dx. So integrate both sides. Find out the general solution first, then only we substitute value to get particular solution. So to integrate this, where our denominator is not linear, so we can use formula number 6, special form, where integrate fx, f prime x, dx, it can bring you back to the ln fx plus c. So let us see our integration here. Do we having the pattern? So the denominator function in terms of y is 3 plus y squared. And when we differentiate this respect to y, we get 2y. So when this one is our function, supposedly we can get the differential function as 2y, but what we have here is just only y. So we can modify the question by multiplying 2 and divide back 2, so that we can get the special form of the formula where this is our f prime x and this is our fx. And when we divide 2, multiply 2, we didn't change the value for this integration. So based on the special form formula, when you're having this is fx, this is f prime x, the integration here will bring us straight away ln to the fx. And then for the right hand side, we just integrate 1, so we get x plus c. Then we have to simplify our solution here into general form where y as a subject. So we try to simplify the 2, multiply it back to the right hand side, it will become 2x times 2c, so we remain it the same constant c. And then when we unlock, we will get 3 plus y squared and then e to the power x plus c. And then we try to simplify the power of plus here. We separate back, it will be 2x multiplied to e to the power of c. So it will be a e to x. So for this ac, since exponential is a constant, c also a constant, so I denoted it as a new constant a. Then y squared equals to plus 3, move to the right hand side, minus 3. Lastly, y will be in the square root of a e to x minus 3. So this will be our general solution as y as a subject in terms of x. To get particular solution, we are going to substitute as student, as question mentioned here, x equals to 2, y equals to 1. So substitute x equals to 2, y equals to 1. So 2 times 2, 4. We try to find what is our constant a here. So we move the square root, it becomes square, 1 square still 1. And then negative 3 plus 3 will become 4. and then this e power of 4, when you move it, will become 4 over e4. Then to get particular solution, we substitute back, where a is e4. e4 at denominator, so we power negative. So you can see exponential time with exponential, which means that we can simplify these indices. It will be e2x minus 4. So this is a particular solution. So every time in solving a differential equation, normally we have to show out what is our general solution first. Then we substitute value to find out our particular solution. And our solution, it have to be in the simplest form as it can. So let y as a subject, simplify until y as a subject. So it should not be remain at this form of equation where this function of y haven't simplified.